Okay. So first things, let me go and create a compute. Okay. So while that is going on, I will take you here and then we'll talk about this. So this is the same what we are doing, right? The data injection process. So this part here, this is basically your batch processing that we do, medallion architecture, right? So we have a Delta Lake, bronze, silver, gold, Databricks engineering. We are ingesting from sources and then we are like processing it and storing in gold, and we are serving it to the BI layer. Can be Power BI, Tableau, whatever it is. So this is out of scope for us, but on the left side we will. So there are, as we discussed yesterday, right? Sorry, not yesterday, last week. We can stream log data, stream from Kafka, IoT devices. We talked about, sensors, network devices that are streaming continuously, streaming the logs, streaming the data. And then from Spark streaming, you can directly read, or you can again have another layer in between called Azure Event Hubs. Okay. So this is similar to Kafka in the concept, but from Kafka, again, you can come into event hubs and store that. So we will talk about what is a event model, right? So real time, what is an event model? How does it work? And then we will also talk about the Azure event hubs, and then we will also talk about the Kafka. So these two we will talk about in the coming sessions. But from here, so this is the Azure event hub on Microsoft Azure. So from here, you can read and do the stream process in the Databricks layer, and then process and then put it into the gold. Okay. So this use case we will talk about, and default they will provide some streaming data that you can stream from event hubs from some default data sets. The event hubs uses Azure Event Hub. Okay. So one of the projects when you put your resume, make sure you include event hubs, as part of one of the projects, and then we can talk more about it, and also Kafka, right? So those use cases. So today what we are going to do is basically revisit the streaming and then come back and say where we have left off, and then talk about how we can integrate with the Spark streaming. The AWS S3, Amazon S3 storage. We will replicate the use case where the files are coming into the Amazon S3, and then you are connecting from Databricks to Amazon S3, reading those files and processing. So, right. So this is the last week what we did for the streaming the files here. Okay. And then group by. So we added this Feb 2025 Amazon. We looked at this data, correct? Yes.
Yes, sir. Yeah.
So we have created raw Amazon products. And then checkpoint directory. What transformations have we written? Oh, we have not written transformations here. We have processed. Did we do transformations on this? No, right? Okay. So we are just doing aggregations. So we are not doing silver here, but we are doing from raw. Okay. We can do a query from the table as a stream. Then we are creating a gold table. we are skipping silver. We're not doing any transformations here. That's why I said there's no hard and fast rule that you have to go through all three layers. But for the example sake, we are just going into the gold. We are doing a grouping on count, okay, main category, and then we are writing into the table using a checkpoint directory that we created. So for checking how we are processing, where we are in the process, if there is any failure, how we would recover all of this. So based on that, we are writing this. Okay. Now let's go back and see if we have. Let me just get this cluster and then run this and see how if I have files in the Amazon. Okay, so we still have the files here. Now, this is the schema. So this part you are all aware of, right? So streaming, if I start run the streaming DF, then it will start reading the files one by one. And then we can get into this stuff, okay? So let's first run this. We are not going to store the data as of now. So let's see how the streaming data frame creates the data, and then how we can do aggregations within the in-memory window. Okay. So for that, see, I'm still using the streaming data frame. There is a streaming data frame coming from this one. Okay. So this is the streaming data frame. So let me first run this. I will also run this. There is no temp data as of now. So here, same things, streaming data frame, group by main category and count. So you are writing to the table here. So you are just trying display here. So what I will do, I will comment this part for now and then see how we are streaming the data. Okay. So are we all good what we are trying to do?
Yes, sir.
Okay. So let me start the streaming here. So once I kick off streaming, then it will start reading the files. And at the same time, I think I also have to. Okay, streaming is coming in. Let me just. I don't want to like it yet. I will just get this. So as and when we are reading new files, we are trying to aggregate that data in memory using the main by group by main category. So how many records are there for the main category? So as we add more files, so it will recalculate the aggregation within the memory, correct?
Yeah, yes, sir. Correct. Yeah.
Okay. So let us see, we are getting files and then we are getting the aggregation here. Okay, so bags and luggage 1824. $29.76. So here initially we are getting bags and luggage. So that is what it is aggregating here. Bags and luggage. Now we have beauty and health. That is data that is coming in. So this is continuously looping or processing the streaming data in memory. So as long as the data is streaming or coming in, it is processing in memory. You can also do the aggregations in memory. Okay, when the live data is flowing through. So have you all downloaded? So now we got appliances data. See, we are not doing or triggering any processing. Okay, it's continuously running the Spark jobs. It's because the stream, we have kicked off a stream. So until you stop the streaming application, it will continue to run and loop the data. It will be same. So if you can actually also do a register the streaming data frame as temporary view. And then you can also run the sequels on the data frame while it is streaming. Okay. So this is your streaming process as and when it is reading. But as of now, see, we have not seen that use case. We have all the files here, but it is picking up as a stream every time one file. It is replicating that scenario that every time it goes in, it will find one file. So it will pick up and process. And then once that is done, it will go back and then pick up another file kind of a thing. So that's what it is triggering. It's replicating that scenario and processing. So it will slowly process all the files, all 50 files, whatever is there. Any questions on this?
Good from my side, Arun.
Okay. So let me stop this and try. So what do we want to do? We can stream that from the read from tables also, and then from delta tables also you can use a delta table which is your Databricks table to stream the data from table as well, just like files. So as and when the data is coming into tables, you can start reading that data as a stream. So that is also possible. And then there is a concept called DLT, Delta Live Tables, where when you create a DLT pipeline, they continuously um, keep all of the tables in sync as and when new data is coming in. You can do CDC, change data capture on that, and then do the processing on the pipeline, all the tables included, and then you get a lineage and everything. All right. So let's say we want to write the streaming data into the table. Of course, the data will be coming in. Again, you can do the query in the table. So we have a gold layer, right? So what I will do here, I will just go and duplicate this another column here, and then just create a notebook. Okay. And go back here. So this is already pre-aggregated. Okay. Amazon categories. How many categories are there in the gold table? So let me use the same cluster and run this. Okay. So I have to put a SQL here, not Python.
Chrome is missing in this.
Yeah. Okay. So table is still not created. Okay, that's fine. Now we'll go here, redo the same thing, rerun it, everything. Okay. So if we can see here, catalog. So the databases are created, but we don't have any tables. Okay. Bronze or gold or whatever. We are not focusing on bronze right now. We already did bronze and silver earlier. So I'm just trying to see how we can get the data into gold and say something we are using for reporting. You can directly read while the data is streaming in. As and when this data is streaming in, the dashboards can, you can refresh the dashboards and see the new data that is streaming in, live data. Okay. So here we have created the databases, right? And now I will start the same streaming here. But this time I want to write the data. Okay. Write the data to the gold table. So how are we writing? So here, see this. I will comment this. I don't want to display here. Streaming data frame, group by same main category. Aggregation, we are taking count. Dot write stream. So earlier we used to do dot write. Now we are doing write stream. Format is delta, Databricks delta table. Output mode is complete, which means we are rewriting the entire data in the table every time. It's like truncate and load, full load every time. Okay. So because the aggregations you cannot append, say for example, in the first 10 minutes, you got this data, say women's clothing 19,200. In the next 10 minutes, you got women's clothing additional 500. So you cannot put two rows, women's clothing 19,000, women's clothing 500, right? Because we are doing aggregates now. We are not streaming and writing as is. So what we will do, we will truncate. So the latest data is women's clothing 19,000 plus 5,000, whatever 24,000. So we want to overwrite. So it will delete this data and then write women's clothing 24,000. So that's what the mode complete is. Option checkpoint location. We want to give one checkpoint directory. It's like a temporary directory we talked about, right? So whenever there is a processing happening, it needs a temporary directory while the process is going on to see till what point it has written the data, where we are in the process, if there is a failure, where it should recover from, and all of that. Processing time we are doing trigger every 5 seconds. To go to the streaming data frame, we'll do the aggregations and override the data in the stream. Okay. And to write it to this table. We'll go back and so we need this one. So we will run this as well. Checkpoint directory. Oh, sorry. Don't want. You don't want the query here. Okay. We just want the checkpoint directory. Some random directory name it will create so that you can use it. Every time you run the job, there will be a temporary folder that will be created. So with some random integer added to the path. Okay. So now, what should we do first? In the pipeline, what is the first step?
creating a schema to load the file.
Yeah, schema is all there.
Okay.
So what do we run first? Read or write?
Read.
Okay, so first we will do read stream, right? So streaming df spark dot read stream. So the moment I run this, will it start? It will start processing.
No, I think the file path, I think it's a, I think
Yeah, file path is
it's a
already there.
different path. Okay.
No, okay. Let's say I run this. So why nothing has happened?
No, the path is different. No, I think you are
No, it's the same path.
same path.
We talked about Spark's lazy evaluation, right? We talked about actions and transformations. So Spark will not start execution until it hits a action. Until you say action, it will not do anything. So what is your action? These are all transformations, still not an action. This is all to create the map, mind map, and create the plan and everything. So display is an action. It has to show you something. So when you run the display, that's when it will start the processing. Again, just like display, write stream is also action. It has to write now. Okay. So once I click this, then it will start the stream processing. Okay. So let me run this. So now it has started Spark jobs. Okay. So now this both of them have triggered. So read is now reading. It's generating the streaming DF because we are accessing the streaming DF here. And then we are writing. So since we are writing here, this will trigger this query. Since this query needs streaming DF, then it will go back and say, hey, I need the streaming DF. Where is it? It says, yeah, here it is. So now start reading and giving me the streaming data frame. Now, as and when I'm writing this, it will start creating the tables. We are writing into this table, so it should start writing into the table. This is the same thing where we are showing display there. Instead of display, we are writing to the table and we are querying the table here. Okay, so first thing now, bags and luggage 1824 tables, rows are written to this table. Okay, it's still the process is running. See, every time you query the table, the count will keep increasing. Right, 29, 76, 66. Then every time new data is coming in, it will start writing, and then you will see the count increasing here. See, bags and luggage, the count is increasing. Right? So now you're clear with the concept, streaming?
Yeah, yes, sir.
Okay. So you can do aggregations while the data is streaming, not when data is at rest, while the data is in motion. The data is coming in, your memory, it's getting appended to the memory, the new data, and then you are doing an aggregation on all of the data in memory, current data, previous data, everything. Okay. And then you're doing doing your transformations on the data in transit. You're doing you're writing the data into the database aggregations while it is processing. Okay, continuous. See, So more data is coming. Now we have processed this here. So let me go and stop. It's still running. So I will stop this. Okay. And then, so that's where we have done this. Now, if I go here, just to show you this. So here, what is the source that we used for streaming? From where we stream the files? Come on, guys, talk. Ramya, where did the files? Where are the files that we streamed from?
Yeah,
Files.
Amazon folder, right?
Yeah, from the Amazon folder within the
Okay.
Databricks file store, correct?
Yeah, yeah.
Okay, so there are a lot of other sources, streaming sources that we set, right? So if you look at any of the architecture, data engineering architecture, there will be a lot of sources on the left side. It will be files CSV, it will be files JSON, it will be XML, or it will be Kafka, it will be event hubs, streaming data, IoT, or Storm, Flink, databases, right? Or unstructured documents, n number of sources will be there here on the left side. Okay, so we only took files from Databricks file store that we uploaded, correct? Now, say for example, a common use case in an organization is, where is the files that are coming in will be in a storage, right? Correct. So where, if we use one of, say, top 3 clouds, we talked about Azure, AWS, and Google, GCP, Google Cloud. So where is the storage? What is the storage for these 3? AWS, what is the storage?
S3 buckets.
S3.
Yeah, S3. Yeah.
Correct. If we go to Azure,
Azure.
talked about it, right? ADLS, Azure Data Lake Storage.
Okay.
Okay? ADLS. So you have to have all of these on your fingertips. Okay.
Okay.
AWS S3, Azure ADLS, okay? Azure Data Lake Storage. So these are all have data lake. Azure has a data lake. Amazon has S3, and Amazon has its own data lake. Google has its own data store, BigQuery, and the Google storage is its own storage. Okay, so any data that is coming in, if these are the clouds, so files will land on any of these storage spaces in S3 or ADLS. Okay. Now, if the files are coming into S3, it can be structured, unstructured, whatever. So there are various ways of integrating and processing into the streaming layer. So Databricks provides that, or using the CDC, change data capture, right? So whenever there is a new data coming in, new file coming in, when you create a bucket in S3 and new files are, somebody is writing the files or vendor is sending the files into S3, some downstream upstream process is processing and pushing the files into the S3 layers, the operational data, OLTP data, transactional data that is coming in, somebody is processing and pushing into S3. We want to take that and generate analytics. Okay, say for example, some organization, okay, 7-Eleven, for example, has stores all over the US and transactions happening. Okay, and I want to see, how the sales are happening, all the revenue across the stores. I want to see revenue by store, for each hour of the day. Okay. For each hour of the day, say from 9 to 5 morning during daytime, I want to see how each store is performing, how many transactions are happening, how much money is coming in. So where do I get the data, right? So the stores, wherever the transaction is happening, the OLTP, online transaction processing, it's called. Okay. And these systems are called OLAP. Okay. These are online analytic processing. OLAP is online analytics processing. OLTP is online transaction processing. So whenever the transactions are happening, so that data will be pushed through all the systems into a store, into some space, some storage, or some programming, some program, some application that is taking in all this data, processing, and let's say pushing into a Amazon S3. So we have put a Amazon S3 storage and said, so this is the use case I'm talking about, guys. It's not just the coding part. Okay, you have to focus equally, more if not equally, on the use cases, because that's what will get you the job. Code will come later. Okay, to get you a job in the interview, you should talk about all of these use cases, talk about examples. You have to first convince yourself, get you into that frame, that you have done this process. Think about it, take any example, and then put your own company name there, and then walk through the process. And that's all. So this is the process. Okay, 7-Eleven store transactions are happening. Okay, they are transactions are streamed or sent to some application or some processing that is happening. They processed and put into S3. Now when they come to S3, from S3 they will from S3 in a bucket, those files, or say their data is coming in files. Okay, and let's say each store is sending one file every 1 hour. They are sending data, or they are just sending data per store. They don't do by hour. Okay, the time is already there in the file, or the transaction time or whatever, so you can use that to aggregate and get the time. But from S3 you want to process using your Databricks, correct? So that is the use case. So and then you get the read, so your source becomes S3. Okay, so you don't want to go, you don't care what's happening before S3 from OLTP systems. They are processing and pushing data into S3, and then you are taking that data, processing it, and then generating the insights. Some executive is looking into the Power BI as a dashboard, and is just clicking refresh and seeing what data is coming in. So what is happening now? I have an S3 bucket, and then I'm processing that S3 data into this. So let's say I have Amazon S3 refurbished and open box tie gifting store. Okay, so this is my bucket, Burak AI. In this, I have folder called Amazon datasets, and in this I have 2 files. So just think about each store sending as 1 file. Okay, or transactions coming at each 1 hour, which has, so it can be that the same file can have data from multiple stores. I mean, that's normally how it is. You don't get a file by store, unless if it is different companies, each company can send you a file. So let's say these are different files having data from all the stores. So as and when the data is coming in, you have to process this data, correct? So first what we will do, we will use the same so we will use this Amazon data set thing, and then see how we are able to do this processing. Let me first delete this. I just want to share open box toy giftings. So let me delete the files. By the way, everybody has access to Amazon S3 created? Know how to create
Yes.
buckets? Anybody who is not done? Guys, talk. Anirudh,
Yes, I
Rahul,
can. Yeah,
Narasimha.
I can create now. I said,
Yeah, I have
yeah.
created.
Okay,
Yeah,
good.
created.
Okay, all right, nice. Okay, you guys are doing good job. Okay, all right. So now we have bucket. In the bucket, I used a create folder and created this folder. Now I don't have any files here yet. So first what I will do, I will go upload, add files. So here I will take refurbished and open box. Simply I am taking smaller files first. Okay, just very small files. Open, just 8 KB. I think 14 or 20 rows are there in this, and upload. Okay, now I have this file. Now I want to switch on the streaming and want to read whatever data is coming into this bucket, this folder. Now let's go back to our jobs and go with AWS S3. So remember, I will share, I don't know if I've already shared this, but I will share this. So there are multiple ways of connecting to S3. Okay. So one is using the Boto3 library. If you are using pure Python, you can just use Boto3 library in Python. Install. So if you want to do, I think we did this right last time when we from Google Colab. If you want to connect to S3, you can do just pip install Boto3. Okay. It is. Oh, this is starting. This is starting. I didn't add this. So you'll install all of these libraries. You have to give the key ID access key. Okay. Bucket name, and then using the session that you have created with your keys and the client as S3, you can connect to the S3. So here you have connect, and then there are some the Boto3 library gives you the functions to interact with the S3. So all functions you can use. This is basically your Python code. Okay. So now you see here, I have only one file. I have only one file here. So it is showing the list of files in this directory. So this is a separating. So there are different ways, as I said, to connect to the AWS S3. So this is how you connect from Python in Google Colab, or if you have your own visual code, or from your local, wherever it is, you can install this library. As long as you have these keys with the Boto3 session, you create a session with the keys. That is your connection to the S3, create a client, and then you can start say using commands with the S3 that are available in the library. So this is one way of communicating and connecting and communicating with S3. You guys clear with this?
Yes, sir.
Yes, sir. Yeah.
So the
Yes,
second
sir.
way connecting from Databricks is because you are using Spark here. So you can set spark.configuration.set these keys. Okay. So F3 FS file system, S3 access key, and secret key. So once you set up these two with the Spark object, configuration object, so Spark will automatically use those just like environment keys. So when you want to connect, it will check if the keys are there, and then it will use those keys to connect. Now, the same thing, you have a schema. Last week we did this. You have a schema using name, main category, subcategory of the file, right? So if you want to see the file, I think it should have the file. Where's the file? I don't have the file. Sure, Databricks. One second. Rates. Amazon data sets. Oh, that's right. Okay. So we have seen this data set, right? So any file, if you open, you will have the same structure: name, main category, subcategory, image, link, all of this. And then we have 24 rows here. Okay. Similarly, I have another toy gifting store. This also has another 24 rows. Same thing: name, main category, subcategory. So this is the schema, right? So what we are doing here, we are creating the schema. Correct? We are creating the schema with the name, main category, subcategory. What are the different data types? And then I'm starting a stream. Oh, sorry. Let me not go to cloud files first. Let me get here. Same thing. Okay. So now I'm going here, read stream. I'm reading that input as a stream, format as CSV, header true, schema is what I created the schema, and this data sets. Okay. This is my bucket. This is my folder, and I'm reading all the files in the folder. Okay. So this is what I'm trying to do. Now, once I read this, I have to display, right? I will use. So my folder is set. I have all the public permissions for this file for now. And then I have one file in the bucket in the S3. I have given the keys. So now what I will go here and run my Databricks streaming job to connect to the bucket and get it. So first I have to run these keys, set these keys for my account to connect to AWS. And then, so I can actually run this and see if I'm able to connect to S3 or not. Okay. So file system, so same thing, right? We are using in DBFS that we are using the LS, but here we are using, instead of DBFS path, database file system path, we are using S3A. Okay. And then it says file info. This is the path. This is the file that it found in the path that we gave. This is the name, all of this stuff. So which means we are able to connect. Now I will run this read stream. So as you know, there is no action here. Now I will go and start this display S3 stream. So this will go and connect to Amazon S3, go through the bucket folder and see what files are there, and then it will start reading those files. Okay. See, it has read 24 rows. So we had only 24 rows, right? Correct? Home, kitchen, and pets category. If we go here and this here, home, kitchen, and pets. Okay. All home, kitchen, and pets, 24. This is first row is header. So 25, so to 24. Guys, are we good? Is this correct?
Yeah.
Yeah.
All right. So what we'll do now, so the application is still running, right? You can still say it's still running. It's still looking for data, right? So what we will do, we'll replicate streaming. Now let's say that 10 minutes has passed or 1 hour has passed. The application is still running. There is no new data. So after 1 hour, maybe somebody has written, or after 30 minutes or 40 minutes, whenever it is, somebody is now writing another file. Okay. So now they're saying, hey, hey, there is a new file that has come in. Somebody is writing the file. So what file they are writing? Adding to this folder, they are adding toys file. That's toys and no, this is the toys and games toy gifting store. Okay. So toy gifting store, the file is now coming into S3, which has 24 rows. Okay. And we are not doing anything to the application, to the job. It is, it's still running. We have not touched anything. We left it alone. It keeps running. Now we go and upload a new file here. Add, toy gifting, sorry. We added toy gifting store. Now I click upload. The moment I upload, the file will come into the bucket, right? So if we go to Amazon data store, now you have 2 files, but this file is already processed by our Databricks job. Now this is still running. We still have only 24 rows. Okay. Now see, it has, see, now it has gone back and checked there is a new file and it has already read those 24 rows, additional 24 rows in that file, toys and baby products. This is home kitchen pets and this is toys baby products. Right? So this is how the actual streaming works. As and when you put more data in, your job is continuously going and reading from Amazon, processing it. That's it. So you can do aggregations, you can do write data into the into your gold, silver, right? Bronze, silver, and gold. All of this you can write. Okay. Any questions?
So, Harun, here we are writing both the files to the same DF object. Okay.
Yeah, it's the same job, right? It's the same data
Yeah.
frame. We are reading
Okay.
from that folder, same data.
Okay.
Now, in the streaming, you can define how much time you want to have this in memory. You cannot keep running this continuously forever, right? A job cannot be running forever. After some time, it might hit issues, it might come out of network. The data keeps accumulating. How much data can you put in memory? Right? So at some point of time, you have to exit, come out, stop the streaming, or clean the data out. Right? So let's say every 1 hour it's sending 10,000 records or 1,000,000 records in an hour. How much data you put in memory? So you have to define the window. Hey, I want to keep the last say 1 hour data or last 30 minutes data in the memory. It's called window. So there are some concepts that we have to look at. What is called a window? How many strategies are there? The sliding window. What is the what you call duration of the window? What is the overlap and what is the sliding window? There are few concepts that you have to define when you are doing this aggregations or window. So based on that, it will actually do the processing, and then the old data it will remove from the memory so that it is already processed, right? So it will remove from memory. Now, for example, let's say you are doing aggregations at 10 o'clock, you have whatever categories 100 and 500. At 11 o'clock, you have 600, 700. Now at 12 o'clock, I said I only want to have 1 hour data. The 10 o'clock data will be removed, but then the 12 o'clock data will be added. Again, it is recalculated. Now I will get sales for the last 2 hours. The last 2 hours is what I define as my window, sliding window. And then I am looking at it at every 1 hour. Okay. It's a little tricky, but if you will understand if you want to, do that. We will talk about it in a bit. But yeah, so that is how you want to see the data in the windows, right? Now we'll stop this. The same thing, something called as cloud files. Okay. Databricks gives you a change data capture using something called cloud files, which means it will trigger autoloader. There is a tool called autoloader, which will run in the background when you do cloud files. So format, instead of just writing like this, streaming, read stream format CSV, here the format will be cloud files, and inside that cloud files format, you will put CSV. You can say, hey, why you need, Harun, we already have, this is working fine, read stream, but why do we need this? So this is more advanced, and then it has more capabilities built in than the regular read stream kind of function. So this can read from the cloud, and it can do a CDC, change data capture. So what I mean by change data capture is, if the data is coming in within the window, it will do the sequence, say at 10:10, whatever data is coming in, generated at 10:10. Now late arrival data, for example, some event happened at 10 o'clock. Okay. We got it at 10:20. Some event that happened at 10:10, we got it at 10:15. So we got the older data later, as latest, right? I think we should look at, but anyways, I will talk about it in a bit. So let's see here. So cloud files, it will capture what are the changes that are happening. It will monitor the folders. It will run the jobs, and it will store what exactly once processing, what files it has processed, what it has not processed. So all of that history it will maintain, lineage it will maintain. So that's called cloud files, which is your Databricks autoloader. Okay. So if you just say Databricks autoloader, okay. What is Databricks autoloader? Autoloader can load data files from S3. See here, everywhere you go, you will have these 3 cloud storage, right? That's what we talked about. Always remember this. Amazon S3, Azure Data Lake Storage, ADLS, into Google Cloud Storage, GCS. Azure Blob Storage is same as ADLS, but you store the blob files. You must be knowing. Blob binary large objects. Okay, you can store that. Gen 1 DBFS is already there. Autoloader can ingest JSON, CSV, XML, Parquet, Avro, ORC, text, and binary file formats. So how does it track ingestion progress? We have a checkpoint location, scalable key value store called RocksDB. So it has internally, it will use its own smaller key value database store, where it will store your checkpoint location. So it will ensure that data is processed exactly once. That's what ensures. That's what you get using autoloader, which is not there in the Spark streaming. Sometimes you might get duplicate data if you just use read stream and do that. So that's why if the data is on the cloud, it's better always to use cloud files, cloud format. Okay. In case of failures, autoloader can resume from where it left off. So if you stop the Spark streaming and then you start the streaming again, so it will read all the files again. So it does not store, it will store within the session. So when you are running the job, it knows what files it has processed, like we did, right? Just now, first file it processed, but when I put the second file, it only read the second file, not the first file again. But if I stop the job and start it again, it will read both the files. But if I do using autoloader, again, in the community edition, I'm not sure if tested, but the functionality is, if I use autoloader, I stop it and start it again, it will still remember, hey, last time I processed this file, so I don't need to process, I should not process this file. So it basically gives you the process, ensures exactly once processing. Autoloader can resume from where it left off by information stored in the checkpoint location and continue to provide exactly once guarantees when writing data into Delta Lake. You don't need to maintain or manage any state yourself. So you don't have to maintain, I read these 2 files, I read these 3 files and all of that, okay? Fault tolerance. It can also do incremental ingestion with Delta Live tables that we have not, so we will discuss it later, Delta Live tables. But that is the autoloader. So all you have to do to use autoloader, there is no installation, there is nothing configuration, nothing at all. All you have to do is just mention file format as the the read stream format, file format, like we are doing here. Just use cloud files. That's it. Okay. And what is the actual format of the file in that cloud location? So that you can, as we said, right, it supports CSV, JSON, XML, blah, 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 all of those. So you can give that, and then you give all the options, schema, and then path. Okay. So it's the same thing here. So let me run this with the cloud files. Okay. Now we have run this here. The same thing I'm starting using the cloud files read stream, using cloud files format, and then I will go display the stream. Remember, now we have, so the folder already has like 2 files, right, in the autoloader there. So it has, I think it has 2 files. Yeah. So 2 files, so 48 rows. Okay. Same thing, you can keep adding data to the bucket. It will, add folder, upload, add files, go travel accessories, open, upload, travel accessories file is uploaded. It will start 48 rows. See now 1000 plus rows. Now the travel accessories data is also there. So this is the travel accessories data. Oh, right. So you can export this to CSV as well. Do we want to check the CSV? This export you can use, open here and go back, see. Okay, only 1000 rows it will show, so you can only export 1000 rows here. But if you want to write it to a, so you can do the same aggregations here as well, and then write to database. Okay, so if I use the aggregation, or if I want to use write to the table, I can also do that. So let me take this. I'm using the cloud files. Where do you want to write? Want to write to the raw layer, or let me stop this. So this is okay. Read stream S3 stream DF. So now instead of display, I want to write this data. I'm just giving some checkpoint location to write. Format delta. Output mode is append. I'm just appending it. And then my delta table. Let's say I just want to write as is raw data dot. Do we have raw data here? What did we create? Let's go to catalog. Sorry, bronze. Okay. Let me go to, let's say, bronze dot Amazon datasets. Okay. Now I will restart this. Remember, we have 2, 3 files, right? As of now, I can check using this. Yeah, so I have open box, gifting store, travel accessories, 3 files. Now I can go and run this cloud files and then write the stream. Okay, so I'll go here to recents, untitled. I'm just using it as a SQL client. Okay. Select star from bronze dot Amazon datasets. Okay, so now data is coming in. I will just do count star. $18.72. So that's, I think, is the total count it has read. Now, same thing, I will go here, close, upload, add files. One, two, three, four, five. I will add upload, all files uploaded. So the job is running, so I don't worry about the job. I will just see if the data is coming in or not. So we have 1872, see now 6,500. Okay, so I think it has processed all the jobs, all the files, sir. So this is the kind of streaming data from Amazon into this, Amazon S3 to this. The same thing you can use. You can from ADLS or from GCP. You can do so. Those are the use cases for you to explore. Maybe we'll touch upon connecting to Azure sometime, but The use case is similar. Using the source, external source like any cloud storage, and then streaming the data, processing, and then writing it. Similarly, we have something called Azure Event Hubs. Okay, that we will do. So for that, the community edition will not work because you have to have Azure Event Hub like this, which is streaming the data or which has a hub spoke model that we talked about, and then the data is streamed and then we process here. Let's go and stop this. Okay, so you guys are all clear with reading streaming. So sometimes you might get error if you write multiple times. So change this path checkpoint location because you ran the job, it stored the state in that checkpoint location. Say, hey, I have done this XYZ processing. I stopped here. You stopped the job. You triggered again next time, but now the state is different, right? So these two are two different jobs instances. Now the memory of this job will not have the, so it has to have its own state of memory. So that's why you have to give a new checkpoint for the job every time it starts, so that maybe sometimes it gets conflict. So when you get errors, just try changing this one. 0, 0, 2, 3, whatever. Whenever you start, just keep changing the checkpoint location. Okay. Also read up on checkpoint location. This is very important. It will be used in the it will be asked in the interviews. Okay, so how do you maintain a state? What do you do if a job has aborted? If you want to restart the job, how will the state be maintained? How will it learn? So all of that. So read up on this checkpoint location, how Spark streaming uses checkpoint location to write, or batch also for that matter, to write data into the tables. So how this checkpoint is used, what it does, how it will help, what problems it solves, kind of a thing. Okay.
Yes, sir.
Yeah.
Okay. Nice. So I have this when you created Azure Databricks or AWS on AWS. I have this Azure Databricks thing I have created, so I can use streaming the Azure event hubs to Databricks because I'm using the same resource group and all of that. So if you go to Azure Databricks, this is the Starbricks demo. Resource group is RG Starbricks demo. So basically you will have create a resource group, managed resource group, and subscription and resource group. Okay. If you go here, so this is Azure subscription. And then if you see here, event hubs namespace. So you have to create an event hub namespace. And in that, you will have an event hub. So you'll use the same resource group here so that they can talk to each other under the same subscription, Starbricks, RG Starbricks demo. This is the resource group. And inside that, you will have your event hubs. Okay, so this is the namespace demo. This is the resource group, and this is your namespace, event hub namespace. In that you will have events. So you can do the event subscription, but if you go to namespace demo, one second. So I'll get you some documentation on how this works. Okay. So you go here, go to Data Explorer. So there is a event hub that is created called Starbricks demo under the namespace, Starbricks namespace demo. So there is a hierarchy that you have to follow. Basically, Azure subscription. Which subscription? One. Starbricks subscription. Okay, so this is the subscription Starbricks. Okay, in that you have a resource group. Okay, so if you go to resource group, RG Starbricks demo, you create resource group here, and in the resource group, so when you create a event hub namespace, so you have to give that resource group RG Starbricks demo and the subscription called Starbricks. Okay, so these two. So once you do this, here you can see you can create an event hub inside it. You give name, retention time, how much you want it to be, to retain, 1 hour or whatever, the details. Review and create the event hub. So once you have the event hub within that namespace, so in this namespace, you have the event hub. So you can go to Data Explorer and then select your event hub. Okay. So what it does is you can have publish subscribe model that I said we will talk about. Send events. It will give you a kind of mechanism where you can publish your own events to the server. So it gives you a pre-canned data sets, basically your example data set. Okay. Or you can do your custom payload. If you want to use your own payload to trigger, that also you can do. Let's say I want to do Hello Taxi data. Okay. So in the Hello Taxi data, so this is, what is the format, this one? What is this format called, guys? Nasima?
JSON format, right? Okay, yes.
Yeah. So this is the JSON format. So this is one element. Okay. It has all of these fields. Able to see this? Okay. Yeah. So this is the JSON format, all of these fields. Then you can send events to a partition using a partition key. So we will talk about what are the partitions, logs, and everything in the publish subscribe model, event hubs or Kafka. So you can do repeat send. How many times you want to send this event? 10 times, and interval after each, how many milliseconds you want to send this event. So 2000 milliseconds is 2 seconds. So after 2 seconds, it will keep sending one event. So it will send in 20 seconds. It will take 20 seconds to send this 10 events, 10 times this structure. It will publish. So every 2 seconds, it will publish this. Okay. Now, so you might say, hey, that might be duplicate data. Yes, it is duplicate data. So we're just using it for testing. But every time, so this message ID will be different. This will be the unique ID. Okay. So message IDs will change. And then you can use this to publish. So this is all like, we are not processing anything. We are not doing any stream. We're just seeing how we can publish the data for some streaming application to read. Okay. So I can do just send. So sending 10 events to Starbricks demo. You can just go view events. See here. 1, 2, 3, 4, 5, 6. 6 events are generated. So now it said completed 10 events. So now you receive 10 events here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. The sequence numbers are different. In queue time, if you see 0, 0, 0, 2, 0, 4. So every 2 seconds, it enqueued one event. Okay. And this is the message ID. I think it should be different. I'm not able to see it here, but it has the same message ID. And the sequence ID is different. Okay. Now event body here. See here, every time it sent the event body, it is using different vendor IDs, 1, 4, 2, 5, 4, 3, some kind of message thing that it has sent. But that is the structure. Okay. So this is how a publish subscribe event based models work. Okay. So real-time event generation, producing and consuming the events. Event hub is something, the same model. Some application can stream data into this, and this can keep it for consumption, basically. Same thing like Kafka also. Okay, so we'll talk more about this in the coming sessions. What is a hub spoke model, events model, how to read and write the events that are generated. So tomorrow, if you have time, after your demos, we will continue with this, or later we can talk about how we can go with this. So any other questions in the next classes? Any questions?
Good from my side.
Okay.
No,
So
Good. Yeah. Mhm.
okay. Yeah. So let me stop recording here.